This week, Paul and I interview Harry Sverdlove, CTO and founder at Edgewise Networks. In the news, a critical SQLite flaw leaves millions of apps vulnerable to hackers. The Signal app states that they can't comply with the new Australian encryption law. And forget shifting left, it's time to race left. Stay tuned for all that and more on this episode of Application Security Weekly.
This is a Security Weekly production. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Rapid7 powers the practice of SecOps. Using shared data, analytics, and automated workflows, SecOps unites IT, DevOps, and security teams to make security an outcome of innovation. Rapid7 combines technology, expertise, and advocacy to drive vulnerability management, application security, incident detection, and log management for more than 7,000 organizations worldwide. Power up your SecOps practice with a free trial at rapid7.com/securityweekly.
Welcome, everyone, to episode 44, our 43rd episode of Application Security Weekly. I am, of course, your host, Keith Hoodlet, and I'm excited to be joined once again by my illustrious co-host, Paul Asadorian.
Hey, Keith, it's good to be here today. Our last episode of the year.
It's incredible. It's 1 year later, and here we are. It's
quite the journey.
It's been an amazing year, Paul. I've really enjoyed this so far. I'm actually really excited for what's coming up in 2019. I just had one of our interviews, our first guest of next year on. And I should actually say, by the way, our 45th episode, 44th of the year. Sorry, bad notes on my part.
We started at zero. That's right.
But exactly. Off by one error, guys. It had to happen eventually. It was the last episode of the year. So with that, one quick announcement before we jump into our interview. The RSA Conference in 2019 is the place to be for the latest in cybersecurity data, innovation, and thought leadership. From March 4th to the 8th in San Francisco, California, we will come live with cybersecurity's brightest minds as they gather together to discuss the industry's newest developments. Go to rsaconference.com/securityweekly-US19 to register now using the discount code 5U as in unit, 9 S as in Sierra, W whiskey, F Frank, D Delta. And that's Foxtrot, not Delta. Sorry. So 5U 9 S Sierra, W whiskey, F Foxtrot, D Delta, to receive $100 off a full conference pass. With that, Harry Sverdlove, Edgewise's Chief Technology Officer, was previously CTO of Carbon Black, where he was the key driving force behind their industry-leading endpoint security platform. Earlier in his career, Harry was the principal research scientist for McAfee Inc., where he supervised the architecture of crawlers, spam detectors, and link analyzers. Prior to that, Harry was director of engineering at CompuWare Corporation, formerly New Mega, and principal architect for Rational Software, where he designed the core automation engine for Rational Robot. Harry, welcome to the show.
Thanks for having me, Keith, and thanks for not going back further than Rational and dating myself.
Don't worry, we will get to that. That comes up at the end of the segment. But in the meantime, I know that networks have been changing quite a lot, especially over the last, let's call it 10 years or so, where we've got all sorts of different challenges arising, whether it's identity-based authentication or even zero trust networks and things of that nature. And I'm sure our listeners would be really curious to know, of course, for Edgewise Networks, what it is you do and how networks have been changing from your eyes, especially given all of your experience.
Sure, no problem. Well, I think the biggest transformation has been we've gone from truly the physical to the virtual. There are no wires anymore. We started in a world where you connected all your wires in a token ring and you had a physical network. And now we live in a world where the network is somewhere else in the cloud, and it's software defined and it's virtualized, and there's layers upon layers. And so there's no place to plug in cords. just as importantly, there's no place to unplug cords when there's challenges. And so one of the things that we do, and the reason why I started Edgewise Networks is, well, how does security work and look in that kind of world where physical wires and physical locations and physical addresses don't mean anything anymore? So Edgewise Networks is all about securing communications, not at the address layer or at the wire, but at the identity of the assets that are communicating. So you can kind of think of it as multi-factor authentication for your workloads, similar to the same way we try to now secure our users with multi-factor authentication, is doing the same with your applications in a way that it doesn't matter if you're in the cloud or you have a physical set of wires, or you're virtualized or you're elastic or you're in a coffee shop. None of that actually matters. And so that's what we do at Edgewise Networks.
That's awesome. Now, with what you do in terms of kind of the, as you put it, multi-factor authentication for devices or applications, right? What are some of the use cases that you see yourself solving today in terms of, I don't know, like maybe some of the big things that you've done in terms of major achievements or major milestones that you've overcome, but also what are some of the problems that you see on the horizon that maybe you're looking to solve as well?
Sure. So, the number one challenge that we solve is lateral movement, whether that's infiltration or exfiltration. And we see this time and time again, where if you think about networks, their whole premise is to facilitate communications, allow as much as possible so that everything can communicate with everything. And of course, that's just, a wide open highway for attackers. And what we do is, and a number of our customers, they use us first to just get a visualization of, well, how are my applications actually communicating? You'd be surprised. There's a lot of stuff that happens on a network that people don't realize. It's not just, oh, my application's talking to my database. There's all these helper services. And we secure those applications independent of anything else running on that system. So unlike a firewall or traditional firewalls where you say, okay, I want this address to talk to that address, over port 22, protocol, TCP, IP, or what have you, we secure, I want my Java application to talk to my database. And one of the challenges and one of the successes that we've had is to be able to do that through independent of these complex virtual network topologies, load balancers and elastic computing and failover situations where workloads are constantly shifting. Based on the load, or you might have a situation on high volume where you have 10 new servers appear, and to have our protection policies actually work through those kinds of configurations. I'm actually pretty proud. We just, a couple of weeks ago, issued our core patent on our ability to do enforcement on application identity independent of topology. In terms of some of the things that we're looking at down the road is how to do that similar type of enforcement for some of the even newer trends that are going on, which is getting away from, we've gotten away from physical wires, but getting away from servers. So you look at technologies like Fargate and others where you don't even own the operating system, let alone the hardware. Of course, that's long since gone. But when you're in an environment where all you own is a container or a microservice that you're deploying in someone else's container and providing that same level of security even in those environments.
And that's so important today as we think about the benefits of deploying applications, especially in serverless. I think a lot of people are just going to naturally move there. And maybe not for every application, right? But for so many applications, it just makes so much sense to do just that, focus on the app and not on the underlying infrastructure.
No question about it. For so long, we've been, if you think about we've been around long enough that I remember the days you had to configure your operating system. You had to configure all the patches, all the supporting stuff that something needed, and then maintain that hardware. And then the hard drives failed and you had to be able to swap them out and then hot swappable. And we got away from managing hardware. Now we're moving away from managing the operating system, and we're soon getting away from managing even the container. And it allows us to focus on, well, what is it that we're trying to do? We're trying to build a service or build an application to do something valuable. All that rest, all that tangential stuff, it's just sort of a means to an end. But just having someone else take care of it doesn't take away your responsibility of making sure they're secure.
It's so true. It's funny, before you mentioned Token Ring, I administered a Token Ring network and learned really quickly not to break the ring because the whole network would just crash.
I remember those days with the little T-shaped connectors, and if you put something in on the wrong end, if you didn't have the right terminator, the whole network went down. I miss those days.
I know, right? Yeah, we had the little clearing thing. You had to clear the port out. I think I have one of those in the studio somewhere. I saved it. So
we've become collector's editions.
Right. But it's true, though. I think much of the, if I look back on my career, a lot of the focus, especially earlier on, was securing what we call the network or the operating system and building it on hardware. And largely that has shifted. I still think we're in that shifting phase, right? I still think so many people think of security as I have to secure and harden my operating system, but that's becoming less and less of a thing now, right?
Well, it is becoming less and less of a thing, but it's still just as much of a problem. So now that you no longer, let's say, you're not managing that operating system, you still need to have faith that, well, who you're renting it from, so to speak, if it's a cloud provider, that somebody is securing it. Because we hear about vulnerabilities, whether it's, even some more egregious ones like Spectre or Meltdown, where just physically sharing the same CPUs as someone else who's renting the same hardware might give them some ability to glean what you're doing. So someone has to be responsible for it. It is an interesting challenge, and I think that we're still not only we need to let go of that, but we need to let go of it in a way that we know that it's still being taken care of as part of the ecosystem of security.
So in terms of kind of modern tech for a lot of people, I know that a lot of them think of this kind of problem as being a firewall problem, right? Would you describe effectively what you folks are doing as kind of firewall for authentication, right? If someone had to simplify the kind of the problem that you addressed earlier, which is you don't want people moving around laterally in your environment that shouldn't be, would it kind of fit that niche? Because I know so many people think, oh, endpoint protection, like, EDR space. It sounds like you're sufficiently different enough to say, okay, we're kind of like a web application firewall for your authentication, but not endpoint protection. Like, it sounds like you cover a lot of those problem sets that a lot of other arenas are trying to play in. And how are you, in comparison to maybe some of those, for people that are thinking, hey, I've got a new budget coming up next year, I'm thinking about these problems that I'm facing, I could go and expand my endpoint protection, but is that really the problem that I'm trying to solve? So I'll pause there and let you comment on that, Harry.
Yeah, sure. And well, the good news is I'm not in marketing, so I have to deal with all the same buzzwords. But I wish I could invent my own new ones. Firewall is obviously the closest approximation, or it is really what we do, but it has a lot of connotations today. So a firewall today, even when they call them if I had my way, I would say what we do is closest to an application firewall. But application firewall sort of been usurped to really mean just layer 7 or packet inspection, a deep packet inspection on physical wires, or at least on addresses, so that the firewall itself is still on the host. It's on anything that's residing on that address, is abiding by that policy, but it's not really at the identity of who's making the connection or who's receiving the connection. And what we do is we're essentially, we are a firewall for the workload, for the application, for the service, whatever's running. And this is very closely related to another challenge that, of course, is a network security challenge, which is segmentation. The whole idea behind segmentation, or even to its extreme behind zero trust, is least privilege. You want to give everything as minimal access as what they need. And if you're allowing access on the wire, or by an address, then anything who can have that address can make that communication. It's called policy piggybacking. So you have access, a similar thing. If you have a phone line to a friend and I get into your house, I can call your friend too. I just pick up the phone. But if in fact security was isolated and segmentation was isolated at the actual identity of what's the service communicating, the person in that metaphor, what's the application communicating, they're allowed to make a connection, and someone else sitting in the same room on the same wire on the same address is not allowed to make that connection. And so the challenge we are solving is a challenge that firewalls are trying to solve today. And next-gen firewalls are trying to solve it with deep packet inspection. But the form factor is much more complicated. When there's no physical wires or taps to put into, it's very hard to get a next-gen firewall in the cloud, for example. And B, they're still using the wrong semantics. They're still basically making their decisions based off of packets, based off of address, port, and protocol, as opposed to based off of who's communicating. In a container world, the microservices, the pods, the containers. And that's really where security needs to get closer and closer to the thing you're trying to secure.
And that's actually the next point that I was going to go into. So especially as we look at Docker taking off and now Kubernetes taking off, and I'm sure that there's probably some competing technology that we don't even know of today that's being built by, who knows, maybe the Amazons or Microsofts of the world, or even yet another startup. How do you see yourselves fitting into that space? short term, medium term, long term? Because I know that at least from a book that I'm reading that we highlighted in the coming news segment called Project to Product, Gene Kim is quoted as saying that we're about 2% of the way through the DevOps movement, which to me is surprising. But that means that there's a lot of room for growth in that arena. So I'm curious to know, for your use cases, what sort of effects you're seeing that you're able to have now in terms of that kind of forward-leaning architecture, and then what sort of things you're preparing for, perhaps, as you're starting to see changes and shifts in the market.
Sure. Well, I think the first way and one of the things we're seeing, one of the biggest drivers for adoption for Edgewise is in the migration space. So let's just say you have either, it could be a legacy application or even a new application you're building on-prem and you want to move it to the cloud, maybe to Amazon, maybe to Azure, maybe to GCP. You're not yet sure. You want to move it to different architectures. And one of the things that by moving security to the workloads, it travels with the workloads. So cloud migration and migration projects is one of the strong drivers. With Edgewise, if you set a set of security policies, how is it that your applications are supposed to communicate? That set of policies doesn't change just because you're sitting in Amazon on an EC2 instance, or change because you're going to Azure, or because you're on-prem. It's the same policies, and they travel with your workloads, so that you build your security once, and then you try different architectures, or you try migrations, or you put a load balancer on, and you try different technologies to see how your application can scale. And as you do that, the security automatically scales with you. And so we see ourselves, and we see by changing the way security is done, that we're able to help customers adopt new technologies quicker, try new techniques quicker. And I think that's pretty important, because otherwise, one of the headwinds to adopting any new architecture is, well, I got to redo everything. I got to redo my technology stack. I got to redo my security stack. I've got to redo those things. And knowing that your security can travel with you or be a part of that whole life cycle, I think is a big facilitator.
Yeah, I really like that angle to it, just based on my experiences, because as we try new technologies or change platforms, as we experienced this year, it can very easily open up security holes. And if I've already applied those security controls around my application, if I can go anywhere and not have to worry about me screwing up a configuration somewhere when I deployed to some serverless technology or some cloud technology, that's a huge win, because there's going to be a whole ton of that moving forward. And to know that I have some protections for when I screw something up, as it's very easy, especially for me, to screw something up in that realm, that's a huge win.
Yeah, and fortunately, you're not alone. A lot of people screw up, so it's okay. You can you can join the club.
Well, and it's just, we talk about the opening up like your Docker or Kubernetes API and accidentally exposing that to the world. That happened to us. That's happening at a much more rapid rate today, largely because people are trying different architectures and platforms. And if one little configuration mishap, all of a sudden it's open to the world, the bad guys are scanning that stuff so fast and taking advantage of it that you need something to protect you against that particular situation, right?
Yeah, no, I think there's no question. It's why we talk about multiple layers, or certainly compensating controls. One of those challenges, if we all agree, we're living in a world where every 6 months things are changing, new technologies coming out, and attackers absolutely are taking advantage of this. Whether it's because you've misconfigured something, which is often the case with some of these newer environments, or either they're just new or they have issues, or there's just known vulnerabilities. All of these new technologies are built by humans. They have flaws. It's natural. There's 19 CVEs discovered every single day. I believe it's 4 of them are critical or high severity. So it's going to be a continuing process, and you can't always depend on, okay, I'm going to catch my error faster than the bad guy, or I'm going to apply a patch or security fix faster than the bad guy. You need to have compensating controls in place.
And now, Harry, it sounds like in your solution, in defining the architecture I was describing, I could say my Jenkins server is here. The only ones should connect to that are trusted developers. And by the way, the Jenkins server, it needs to talk to my Kubernetes server to do automated tasks. So Kubernetes trusts my Jenkins server. I can apply those rules and then go put it wherever I want. And those rules follow it?
That's correct.
Oh, that's awesome.
And they follow the identity of that. So wherever that Jenkins server is, wherever your Kubernetes cluster is, it will follow those where they go. The Kubernetes API, that recent vulnerability that was discovered last month, is a perfect example of where you let something out, and a malicious person can then use that to essentially, again, back to piggybacking. can
Right.
piggyback on your existing policies and have these communications with all of your pods as if they're secure.
That use case really resonated with me. That's awesome.
And going back for just a moment to the idea of portability as well, Harry, for your experience so far, at least for what you're seeing, a lot of people, of course, are making the migration to the cloud. Some people are saying, okay, the cloud is now too expensive. We're actually migrating back to our own data centers, ergo, like the Netflixes of the world, for example. It sounds like your technology is wildly portable from a container space, but also, how do you play into kind of that serverless architecture, if at all, right? I mean, that is one of those things that do you have maybe its own API instance that it can make a request to within the serverless technology? Because a lot of people tend to be looking at that as maybe the leapfrog to containers today, and some people are starting to consider how they can use that. Is it that Edgewise would sit on the main application with the functions as a service being what they are for whatever functionality, or are you actually bundling into any sort of the Azure functions or the Lambdas of the world as well?
Right. So yeah, this is a couple things there. So first is when we built the technology, we wanted to build it platform agnostic. So it works on-prem, it works in the cloud, and we built that. We wanted to keep certain principles so that we weren't dependent on only a certain set of APIs provided by a cloud provider. And that gives us that portability, that gives us the ability. I think we support now, it was last count, well over 400 different distros of Linux, almost every variation of Windows. So almost any platform operating system out there for the serverless functions that are provided by clouds like RDS and Lambda functions, we can control, at least on the managed side, any of your software that you manage, any of the hosts that you manage connecting into it. And you kind of think of it as a sort of like a dead man switch, where Edgewise is controlling the communications into those things. And if anything goes wrong, any system either is reporting unhealthy or some suspicious patterns are connected, essentially we drop the handle on the button and all communication is stopped to that third-party service. Obviously, what we want to do, and our goal moving forward, is we want to have that same level of identity authentication present on the other side, the serverless side. So if it's Fargate or if it's Lambda functions, and that requires the same principles we want to achieve, but it's going to require a slightly different technology approach because obviously the form factor is different. There's a number of different competing ways that people are trying to solve this problem with sidecar containers, with your own libraries, and we're looking at a number of different approaches so that we can apply that. What we want is we want a technology that at the end of the day, whatever's receiving, whether you own the container, whether you own the server, it is authenticated, is cryptographically authenticated, the identity of who's making the request or receiving it, and is validated. Today, we're able to do that for at least all of the managed components of your application going into or coming from the third-party serverless services.
Gotcha. And I can definitely see it being a situation where in your serverless function, you've got to call out to maybe another serverless function that you're offering right now. So you're selling them a serverless function that is spun up in Lambda or whatever, to be able to then, okay, they can quickly authenticate inside of their own function, whether or not it's an authenticated call.
Exactly. You kind of think about it sort of like, a secure registry. You make a request, you say, I want access to whatever, and you have a named service that actually could go through Edgewise, and we would authenticate both. Are you allowed to? And then based on your cryptographic identity, either give you that access or not. One of the other things that I think people don't realize is even in container environments and all of these serverless environments, there's a lot of times your application, if you're integrating in with identity or Active Directory services or DNS, you're relying on a lot of third-party services that aren't necessarily containerized or running on the same system. And so that's another reason we wanted to make sure our technology approach worked outside of the container as well, because there's still a lot of communications that happens even in quote unquote isolated environments that isn't so isolated.
That's absolutely true, especially with the things that I see working at Thermo Fisher Scientific. We work with a lot of labs, for example, and a lot of them have air-gapped labs, but that doesn't mean that they don't have communications happening within the lab. It just means that there's no internet connectivity to the lab. Right. So that can be a whole host of problems that you're solving as well with what you do, which is awesome. Paul, do you have any additional questions before we jump into the 5 questions for Application Security Weekly?
I like that because it can do it from the beginning. And kind of what Keith was talking about reminded me of, developers in sometimes working with, sometimes not working with network systems or security people, right, will develop the initial framework. And I think developers understand what the trust relationships need to be right from the beginning. And if they're building those in, Where I see a lot of problems are as the application starts to get larger and try and trust more systems and move into different staging environments. That's when you start to notice problems. But if it's done from the beginning, speaking of shifting left, I think that's another big win.
Yeah, there's no question about that. This whole idea of enabling and empowering earlier. Definitely curious to see how we run left, but we're certainly seeing a shift to the left. It would be great if it was a sprint. I'll take a run.
Agreed.
Absolutely. With that, Harry, are you ready for Application Security Weekly's 5 questions?
I am ready, and being that I'm the last person to answer these questions for 2018, hopefully I'll do them justice.
Awesome. So we did promise we'd get back to dating yourself. So the first question we have is, what were the specs like on your first computer?
Oh, geez, a TRS-80. It was, I think, 8 kilobytes of memory. I had a tape storage device and a very tiny keyboard that, funny enough, now that I think about it, it kind of reminds me of an iPhone keyboard today. So I think we've gone full circle.
Nice. The other question we often ask is, what programming language did you learn first? And to what extent, if you're writing any code today, what do you enjoy writing in?
Okay, so this is going to date me really badly, but I was 10 years old and I went to the first computer camp that had ever been created. Yeah, that's really nerdy, but they did other things like archery and other stuff, but it was the first computer camp. And the first language I learned 3 languages that summer. The first was Logo. So I had the little turtle, forward 50, back 50, right, left, your basic geometry. And then I also learned Pascal and BASIC, but Logo was first, and I'll always have a special place in my heart for that little turtle.
Nice. Now,
also, we're going to pull you into I think I missed.
No, I was going to say, if you're writing any languages today, if you enjoy writing in anything, but
today sadly I don't get as much hands-on as I want, but the language that I use most often than not is Python.
Yeah, that's a common one. I mean, it's one of those things that it's hard to, if you do it wrong, you'll know pretty quickly that you failed fast, but also it's kind of nice because it has good, spacing and form factor to it. So logic flow is one of the things.
I do love it. It took me a while to adjust to the fact that spaces matter. And I tend to be from that old school of thought. There's a whole debate sort of like VI versus Emacs. Do you use tabs or do you use spaces? And that distinction, I used tabs and others would use spaces. You can't mix and match in Python. So a lot of fun philosophical debates over things that in the end don't really matter, but they definitely matter.
Mm-hmm. Well, it's funny because we're going to actually ask you about those philosophical debates. So first, VI, Vim, or Emacs?
Emacs, hands down. Sorry. Always been an Emacs guy.
That's okay. You might have words.
Some people will hate me for it, but I will die with Emacs. And on Windows, I used a program, actually Lugaroo software called Epsilon, which was Emacs for Windows. And it allowed you to open a command shell inside the editor, which was unbelievably powerful in those days. And so I've always been an Emacs fanboy.
Right on. So the other question, of course, is spaces or tabs. It sounds like you use tabs. Did we convert you to spaces somewhere over the last number of years, or are you still a tabs guy?
No, so I'm a tabs guy, but I using my Emacs, I changed them so my tabs become spaces. I had to convert to spaces because we now live in a world where, look, I started when I started coding, everything fit on it was an 80 character screen, and you could do your 8 space tab, but it was just a visual spacing. And then eventually you started adjusting your tabs to be 4 space and then 2 space because lines got longer and longer. And then all of a sudden editors discovered auto word wrapping and auto indenting. And eventually just tabulation started losing some of the original value it had. So today I am a tab guy, but auto converted to spaces.
Mm-hmm. Gotcha. For me, I always just set up my tab as 4 spaces and call it a day is usually what I run with. So I totally hear you there. Exactly. Last question, though. What sort of advice would you give to newcomers in the industry, given, again, your history of experience and all the different things you've done?
So, I guess I can go a little bit on a soapbox here, but the advice I would give, and because of just my own experience and just also watching the industry and all of the different languages have developed over the years, whatever you learn, I don't care whether it's Java, Go, Python, take your pick, Ruby, Don't just learn the language. Don't just rely on other people's frameworks. Developers today, sadly, I think a lot of them have become lazy. So they just go off to, SourceForge, they download a bunch of free sample library kits of this, that, and the other thing, and they never understand what's actually happening. I came from a day and age where it actually mattered how many bytes your code compiled into. And so you thought about memory usage when you did things. You thought about the impact of everything because everything mattered. And now we just don't care. And I get that CPUs are cheap and memory is cheap, but the best coders I know don't just rely on frameworks. They understood the difference between using one type of conditional versus another. They understood how exception handling worked, how inheritance worked, and what was happening under the covers, so that when you rely on some third party, which is fine, don't reinvent the wheel for sure, but you understand what they're doing, and it makes you a much better developer without question.
I agree.
Absolutely.
I have the same advice with anyone in security, right? Or really anyone in IT. I think I agree, because you can go create all these things up in the cloud or serverless, but if you haven't built the underlying infrastructure by hand, I go back to my wife's example in X-ray school, they made everyone build an X-ray machine. So you understand the technology that you're using. And I think it's a great analogy to, our field today.
I studied, even though I was programming since I was 10, I studied electrical engineering in college because I wanted to go that step further. One of the projects we did is we built an Apple hard drive.
Right.
I wanted to understand how things worked under the covers, and it just gives you a much better understanding today. Now with modern environments, microservices, I have as many third-party dependencies in our applications as we have actual microservices. And when something goes wrong, or the tubes are clogged, so to speak, and you ask the question, well, what went wrong? So many developers go, I don't know.
Yeah.
There's 20, 30, 40, 50 components going on. I don't really know what's happening. It's voodoo magic, and it shouldn't be, because it's really not at the end of the day.
Right. Awesome. Thank you so much, Harry.
With that, check out edgewise.net/securityweekly to learn more about Edgewise Networks and all the good things they're doing. Harry Sverdlove, thank you so much for joining us. With that, we're going to take a short break and then come back for the news.
All right.